Okay, we're going to hear now from Patricia Falco and from Annet Dekker. Trisha Falco is a time-based media conservator at Tate London. Her role includes the conservation of new time-based media artworks coming into the collection. She is part of a team at Tate developing the processes necessary for preservation of digital artworks. During 2013-14, she researched the use of virtualization for the preservation of software-based artworks. Ms. Falco completed her MA at the Bern University of the Arts, Switzerland, and a thesis on risk assessment for software-based artworks. She continues to develop research in this field within the ambit of Pericles, a pan-European project that aims to address the challenge of ensuring that digital content remains accessible in an environment that is subject to continual change. Annet Dekker is an independent researcher and curator. She's currently researcher digital preservation at Tate London, a postdoctoral research fellow at London South Bank University and the Photographers Gallery, and a core tutor at Piet Zwart Institute, Rotterdam, Master in Media Design and Communication, Network Media, and Lens-Based Media. Previously, she worked as a web curator for SCORE, Foundation for Art and Public Domain, and was a program manager at Virtual Platform, a head of exhibitions, education, and artisan residence at the Netherlands Media Art Institute. From 2008 to 2014, she wrote her PhD dissertation, Enabling the Future of How to Survive Forever, a study of networks, processes, and ambiguity in net art, and the need for an expanded practice of conservation at the Center for Cultural Studies, Goldsmiths University, London. Please help me welcome them.
Hello, welcome everyone. First of all, I really want to thank the TechFocus committee team for inviting us actually for this very fascinating 2 days. I was just in the break discussing indeed with Patricia, my colleague, who will be standing here soon as well, about how an enormous change has happened over the couple of last years. I remember about 10 years ago or so, I would talk about the conservation of software and people would look at me like, what are you talking about? And here we have a whole full room. So I'm really looking forward into the future. This is going to work. We're going to make it work. So, good. Without further ado, we actually going to be repeating, I think, and also agreeing a lot with what has been said previously already. But yeah, take note of that and see where you can spot the differences as well. So in a museum that collects software-based artworks like the Tate we'll be discussing now, we want to preserve the work as best as possible. And since preservation tools for software-based artwork are only just starting to emerge, for the works in Tate collection, which all run on an x86 computer architecture, a few years ago we began using virtualization as part of our workflow. And although we don't recommend virtualization as a sole preservation method, other forms of documentation are still very useful, and essential even, we believe it's a very good way to test and learn about an artwork. So rather than strategy, we regard virtualization as part of a toolbox. And currently we are experimenting with virtualization during the acquisition phase of an artwork. After 2 successful experiments, today we will show you how our third case, the recently acquired work Sow Farm by Gerrard, really tested the limits of virtualization at this moment. Now, I will first briefly describe the work Sow Farm, its main components and the significant properties, and next Patricia will go into details of the virtualization, the difference with emulation, the results from our first experiments, and how we are implementing virtualization in our workflow. First of all, though, very brief, what do we mean when we talk about virtualization? And although many definitions are around, we use this following description. Virtual machines contain everything that their physical counterparts do, but they're only packaged in a set of data files. And we use virtualization for different reasons. It makes the work independent of hardware, it creates a backup that can be used for testing, and although, of course, similar to other software, it will become obsolete at a certain point and needs to be maintained. At present, it serves really useful purposes. The virtual machine and the process of virtualization are also useful as documentation. In the process, one can learn several things, as Patricia will also come back to in a minute. And perhaps most importantly, though, it's very user-friendly, and you probably all know this because you've already installed it on your computers for tomorrow's workshop. It is, though, although it's easy to learn, we do think it's important to have a consultant to check with you if it functions properly. And again, this is not necessarily someone really difficult to find. You might actually find it in your IT department, or your IT person will actually know someone else who can help you find someone. Now, before Patricia will tell you more about how we use virtualization, I'll briefly say a few things about our current case study, Falcao, by John Gerrard. There we go. Oh, that's the wrong button, sorry. Yeah, there it is. John Gerrard is an Irish artist. He works in Dublin and Vienna, and in 1996 he came across 3D scanning, which was then primarily used for commercial or training purposes. He saw, though, the potential for art making and began creating sculptural photographs. His work is best described probably as post-cinematic, performative, and ultra-durational, prompting viewers to experience and not just watch portions of action that are either infinitely continuous or programmed beyond their lifetime. Often Gerrard's exhibitions are described as simulations, sorry about that. They actually look like video works, but actually they are complex real-time computer recreations of actual places. Now, Gerrard made Falcao near Libby, Oklahoma, in 2009, and it presents a portrait of an agri-industrial complex in the Midwest of the United States. It depicts a series of iron sheds, examples of intensive livestock farming of sows. And as mentioned already earlier by Joanna and Christiana, to view the whole work, one needs to sit in a gallery for 365 days. And during that time, one might see, or will see if they really stick around, 2 or 3 times every 156 days, a truck pulling into each building. It will wait for 1 hour before disappearing again, really reflecting the growth cycle of the enclosed pigs. Now, the work is made by taking thousands of photos, and these photos are used in a studio to reconstruct a hand-built virtual 3D model of the space, which in turn is then placed within a virtual world. It incorporates the passing of time and other environmental elements as well. Now, Gerrard's choice of medium is very closely tied to both the content, the form, and the making of the work. The computer and its capacity to model any system whatsoever is the crucial enabler, not only of the hyper-realistic cinematic type rendering of his subjects, but also of the globally coordinated networks of production and distribution that the works explore. Now, the work really is very highly labor-intensive and a collaborative affair. And usually it takes about 6 months to a year to actually finalize. And here you see all the collaborators. Well, you can't probably really see them well, but what's quite interesting that he names them all in the credits on his websites as well. So it is this family of people that actually makes the work happen. So what did the artist supply at acquisition? A version of the art objects, similar to actually one of these monitors, custom-made monitors, I have to say, which has an inbuilt computer on which the software is installed. The monitor is aimed at collectors and private displays, but in museums, Gerrard wants to display the work as a projection. And as part of the work, the artist studio also supplied a folder with the software, setting files and extra libraries needed for install, and the installation instructions. And it's also specified that the artist prefers to be consulted when planning display of the work. Since I didn't supply the computer for the projection display, we installed the software on a computer that we bought after consultation with Gerrard's team, who recommended the purchase of a high-spec computer and an NVIDIA GTX graphics card. And this is what the card looks like. The card is actually is mostly used for gaming, and that shows you again this sort of interaction between different fields at the moment. And through discussions with John Gerrard and by running the artwork prior to the exhibition, we defined the significant properties, or work-defining properties, as mentioned before by Mona, as follows. The image must look as realistic as possible, and the camera needs to move smoothly. Thus, the rendering of the image is very important. The timing is also very particular because the movement of the sky, which is independent from the movement of the camera, is programmed to match the time and the date in the computer that is used for display, so that the sunrise and sunset happen at the set times in the gallery. Initially, the instructions were for the computer clock to be set at the location of the real farm in Oklahoma, but that proved to be a problem when the time difference was too large. And so the instructions are now that the difference between the real time and the model time should be noticeable, but do not need to be exact. And finally, Gerrard wants the projection to be suspended in the space. And you can see that a bit here. You see a bit of the shadow here. So besides having the software running correctly, it's also very important to have the correct gallery layout, wall colors, type of floor, and projector. So now I will pass on to Patricia, who will describe in more detail how virtualization can actually be used to maintain some of these significant properties or not.
Hello. So as Annet mentioned, I will briefly explain what virtualization is in very simple terms, and just going back, sorry, I forgot to move this. And because emulation is a very closely related technique, I was asked to discuss briefly the key differences between the two and how that affects how you can use them and for what purposes. And in fact, this would also apply to emulation, sorry. So to start with, virtualization was developed by the industry, so companies like Oracle or VMware, and it's currently used in most IT departments for their server infrastructure, to manage their server infrastructure. And the main advantage for them is that it allows them to run different operating systems on one server so that the hardware is used to its fullest capacity. The other common use is to create and distribute virtual computers already set up to run specific software, which is what Ben did for the virtual box, for the virtual machine that we'll be using in the workshops tomorrow. So let's just look at some of the details for virtualization. So if we follow what we were thinking, if you think about your laptop, you'll see that this is your laptop, and it's running hardware on x86 architecture, and it will be running an operating system on top, probably not Linux server. And on top of that, you would have the virtualization platform, which would be VirtualBox in your case. And then on top of that, you can run your virtual machine with a guest operating system and an application on top of that. And part of the relevant part in the hardware is actually you are running, it includes the central processing unit or the video cards. Sorry, I got lost. USB ports, that sort of thing. So the difference to emulation is that, so what I couldn't represent in this diagram was that system instructions in the guest operating system are executed directly on the host's central processing unit. So you are literally addressing the hardware. And this means that only operating systems that use the same instruction set and architecture of the hardware CPU can be virtualized. Currently, the most common architecture is x86, which is used, for instance, in Windows systems and Linux systems, as well as Mac OS X. So you can easily run Ubuntu on your Mac or your PC, but you wouldn't be able to run an old version of Mac OS on your PC or your Mac, actually. And this is where emulation comes in. So even though emulation sounds very similar to virtualization, in that you can run a computer inside a computer, but emulators can run software designed for architectures different to the ones of the host computer. And so I'll just make a brief comparison between the two techniques. So in emulation, every system instruction must be translated to execute on your host CPU. And this means that host and guest systems can use different architectures. Usually, one emulator can run software for one type of architecture. So emulation is currently being actively developed by the gaming community, mostly people who want to understand and keep access to old arcade games or early Mac operating systems. But there's also a keen interest in the digital preservation community. Because the architectures of the systems can vary widely, emulators tend to support a limited set of operating systems. For instance, you can use ShipShaver for macOS, early macOS versions, but that's that's what it supports. Because in virtualization, any system instructions are processed directly on the CPU, the support for peripherals is better than in emulation, and the processing is usually faster. So for something like SoFarm, it would make sense to choose virtualization. In terms of the communities, and this is an important point, emulation is mostly community-based and open source, and this means that the quality of the emulators and support will depend on the community and on how this community evolves. On the other hand, virtualization is aimed at the industry, and processes and formats are more standardized. Also, like Annet mentioned, the knowledge about these tools is also very likely to exist in any IT department. And also, most virtualization tools will have support. The downside of being aimed at the industry, of course, is that support for legacy operating systems or specific features is likely to be dropped with time, and as soon as these features become obsolete. And also, most platforms are proprietary, with the exception of VirtualBox. And now I'll discuss the advantages and disadvantages of virtualization. So, virtualization is not a solution, it's a tool and a process in the way we see it, and it just helps us to understand the work better. The key limitations are that it only supports system using the x86 architecture, so more recent works probably. And there are limitations to the peripherals that it supports. But the interesting thing is that this really evolves very quickly. So we didn't expect to be able to virtualize SoFarm because it uses a very recent version of DirectX. But actually, a few months later, there was support for that. Virtualization is software, so it will become obsolete. And the final point is that even though you may be able to run a software in a virtual machine, it doesn't necessarily represent the artwork faithfully. So when you produce it, you need to be able to compare it and make sure that it is correct and that it is doing what it's supposed to do. The other points that are interesting is because you can vary some of the hardware parameters of a virtual machine, you can use those features to see the effects of them changing. So for instance, processing speed on the performance of a specific software. And if the virtual machines are created carefully, then they can maintain those significant properties over time. And the virtualized version can then be used for comparison when producing a new version again. Virtualization does mitigate the risk of hardware failure, so it's a good option if you need to run a software and there is a risk of your original hardware may fail, and virtualization is a tool, so it helps you to learn about specific artwork, but it's only helpful within a general workflow together with other steps, which I'll now briefly explain. So at Tate, acquisition is the moment when we get the time and the budget to research into new artworks coming into the collection, and also to consider how to preserve it. So it's at this point that we learn about the artwork's production and technology and define what's important to preserve and to ensure that the work can be displayed for as long as possible. We do this by working closely with the artist and programmer, as it's been clearly stated here, to understand the significant properties and the dependencies of that artwork, creating a technical documentation of the systems and storing and maintaining those hardware elements. You will hear a lot more about creating these images on the workshop tomorrow, so I'll leave that at that. But as was already mentioned, we also found essential to create a second version of the hardware and software system for exhibition purposes, but also, as Kate and Ben mentioned, as a way of learning more about the work, because when you install it anew, you will find any library that you're missing, it will probably tell you, so it's a very good thing to do. With virtualization, we are adding to this workflow to address the dependency of an artwork software on specific hardware and enable the work to be contained within within a file and make it more portable. These files can then be safely stored with the other digital assets that are related to the artwork. So now I will go very quickly into the case study itself. So like we mentioned before, Tate has successfully virtualized to software-based artworks. They were older and simpler maybe, not, but they were slower than SoFarm. And because we knew SoFarm relied on the graphics card, we thought this would be a challenge and that we would run into problems with virtualization. So we decided to try it anyway. So we wanted to try it, and we also wanted to try a couple of different virtualization tools. And this is just a very quick summary of the tools. There are more virtualization tools. These are the ones we looked at. And what we found was that SoFarm would run both on VMware and Parallels, but actually we had trouble. We couldn't make it run on VirtualBox. We haven't given up yet, but we'll keep trying. And next, I will show you two screen captures. So they're videos of what is displayed on our screen. The first one is the artwork running on the computer, as you would see it in the gallery. And the second video shows you the virtualized version. And now, hopefully, it will. Yes. And what I want you to look at is, so this is the version on the hardware. So it's what you would see in the gallery, is to look at how smooth the movement is. And the whole 365 days are like this. It's just very slow pan around the buildings. And now I'll move to the next video. Maybe. Okay. And this is a virtualized version. And what I hope you can see is there is a slight lag in the movement. And there it just stopped because the data on the top appeared. And this is the other thing we've learned we only found about this because we were testing trying to virtualize it, and we were trying to find a good way to assess whether it was correct or not. Because the text on the right-hand top of the screen is actually information about how the software is running. And it's not visible when the work is on display. But it's very useful because it will tell you the frame. Oh, no, that was too fast. So it will tell you, that's the button I want. It will tell you the frame rate at which it's running and how far along the programming is, how many days, the memory. It has a lot of useful information there, but it's only visible if you know you need to press this one button. And this wouldn't have come out if we were looking for ways to evaluate the results of virtualization. So when we talked to Gerrard, he was like, oh no, you press that and it will tell you the frame rate, and then you will know if it's running at the right speed. So that was quite handy. So in summary, what we think is that virtualization is useful and can be used and is constantly evolving with new features being added. It's also likely that these features may disappear once obsolete. Virtualization is a good method to document what we have and can be an alternative way of viewing a work. In the case of SoFarm, this is not true, obviously, because as I showed you, there are subtle but obvious differences. However, we have used virtualization successfully to mimic other software-based artworks at the Tate. So basically, virtualization is an excellent way to test your artwork, but also test what the artist tells you about it. So we will end on this note, and I just would like to thank the organizers of TechFocus for inviting us, but I would also particularly like to recognize the contribution of the team at Tate. So Brian Jones from the IT department, Jack McConchy in time-based media conservation, and Matthew Allam, our freelance programmer, who, and I think we had a very enjoyable time just testing this. And it was really important that we were all working together and with different knowledge about different parts of the systems. We would also like to acknowledge the relevant discussions with John Gerrard and his team, and also with the members of the Pericles community of practice in software-based art, which it's been a very interesting discussion. And finally, I just need to make a shameless plug to the upcoming Media and Transition Conference at the Tate in November. There are leaflets on the registration table, and I think it's going to be very good.